Okay, so today we are going to play with asynchronous programming. Last week we saw a very quick example of a timer where some operations were scheduled to happen in a different time with respect to the point in which the instruction was written, was executed. And today we are going to learn and play more detail about these topics. Basically, what we mentioned last time is that JavaScript is a single-threaded language, as a single-threaded execution model. So actually, there's only one instruction at a time being running, being in execution. Well, more of that, there's only one function at a time under execution. So the unit of execution is the function in JavaScript. A function may start, and once it's started, it will run to the end. We have two different types of functions that are run in a synchronous way, and functions that are run in asynchronous ways. Okay? And all of that is just in a single-threaded application. So you have no problem of real concurrency. It's just a collaborative execution and collaborative asynchronous, message passing or handling. How does this work? Well, it works inside the JavaScript interpreter, both in browsers and in Node.js, thanks to a data structure, basically, which is called the event loop. So from the memory point of view, we see that the JavaScript environment is quite traditional. So we have some memory heap where all the objects are allocated. So when you create a new object, it goes into that memory area, and we play with the references and so on, from the point of view of data storage. From the point of view of code execution, we have a normal stack where functions may call other functions, which may call other functions, that add the normal stack of procedure calls, or function calls, one on top of the other. This is just running in the traditional synchronous way. Okay? But then, on the side, we have a queue. Actually, it's a priority queue of functions wanting to be executed. A function that we should execute sooner or later, and they are waiting for their chance to be put into the call stack and start the execution. Who's going to put new functions in this queue? These are just I repeat, they are functions. They are not just statements. They are complete functions. Imagine you have a call to a function with all the parameters, with all the context, all the closure information about that function call, and you put it aside. Okay, I should do this sooner or later. Okay, and when and this happens normally when there are some external events, asynchronous events, that trigger the execution or the enqueuing of a new asynchronous function. So there are moments in which the JavaScript interpreter, or basically more the runtime environment in which JavaScript is running, is generating some events. An event may be a user action. A user clicks on something, and I want to handle that event. Handle an event just means running a function that I define to take care of what happens when the user clicks there. Or an input-output operation is completed. I started the connection to a database, and the connection is ready. I started calling on a server API, and the server responded, and so on. So there are events that are either coming from the user or coming from some input-output operation that I created, or some timers that I set, That will happen sometimes. When this happens, they don't interrupt the currently running function, but they're just put into this queue waiting to be executed. When the call stack is empty, and in a synchronous language, when the call stack is empty, it means that the main is returning and the program is finished. In JavaScript, this doesn't happen. The program is practically never finished, because we have usually, in JavaScript, we have something running in the browser, and the browser is still there. Even if you are finished executing some code, the browser is still there. Simply, your JavaScript program doesn't have anything to do. It just has to wait for something to happen and to have something to do. Or if you have implementing a web server in JavaScript, the server is still listening to a new incoming connection or requests. And until there are new incoming requests, it has nothing to do. So there will be no running function in the call stack. It happens. It happens frequently in asynchronous languages like this. So there's nothing to do, and so the interpreter will pick the first item in the queue and put the call to this function onto the stack and start executing that, start running that. And that may call other functions, which may call other functions, and so on, in the synchronous way. So this call stack will populate with other function calls, and then as this function return one by one, the call stack sooner or later will become empty, and when it becomes empty, I will pick the next function from the asynchronous queue, and so on. So I have a queue of functions that need to be executed asynchronously, but one by one, in turn, they will be brought into the synchronous execution environment, and they will be executed synchronously from the first to the last statement. Of course, also the execution, synchronous execution of some of these functions may cause the scheduling of other asynchronous events. If I'm doing something, then maybe I initiate an input-output operation that will return, and then when it returns, it will enqueue another operation there. So actually, there's a synchronous operation in the language, a function calls another function, which calls another function that will return in the reverse order, normal synchronous function calls. Or I'm scheduling some events to happen in the future. And when these events happen, they will add something to the event queue or to the message queue. And at any step, the interpreter will check if we already have something in the call stack, I must execute it. If the call stack is empty, on the other hand, pick the first function call from the queue and start running it. A function call is never interrupted. This means that if I have one function that sits in a loop or takes a long time to do something, it will block all other functions. This means that we should start thinking about async functions that should be run asynchronously, and they occupy the CPU, the interpreter, only when they really have something to do. And whenever a function needs to wait for something to happen, it should release the control. It should never still sit waiting or doing something which is not really necessary right now. Okay? Because otherwise they will slow down all the rest of the code. So the idea will be we write functions that try to be quick in the execution, do something and go away. And if some task needs to be completed later on when we have more information, then we will schedule the completion of this task asynchronously when this information will come. So even something that in our mind is synchronous, we should split it, okay, in a first part, and then we schedule something to complete later on. Today we'll play with the database. Okay? In our mind, when I send a query to the database, I wait until the database returns. Okay, and in many languages we have asynchronous waiting because, think, for example, if you do that in Java, the wait normally is synchronous. We send a query, we wait for the result in JDBC, for example. But this is normal because that language is a multi-threaded language. So if we have to do something in parallel, I don't know, update the user interface and so on, it will go on in separate parallel threads. So if one thread is waiting, it doesn't, well, actually it will release the CPU for the benefit of the other parallel threads. Okay? In JavaScript, there are no parallel threads, there are only one thread. So the only way to give the CPU to others is just to finish and reschedule the execution later on. So it's more explicit, it's more collaborative, this kind of multitasking. I try to be quick with what and doing what I can do now, right now, and then I go away and then just schedule myself for later on when I have something more to do, if I have something more to do. So that's the idea, okay? And we will see that, okay, the need of sending something for the future or scheduling something for the future is much more frequent in JavaScript just because we have only one thread, and so we must share the thread between other needs, okay? So this is the general framework. From the practical point of view, there's nothing special, let's say, because asynchronous callbacks are just callbacks. I'll give you an example here of a library that we are not going to use, just to give the flavor. Imagine you want to read something from the keyboard, okay, from a console. We know console.log, but there's no input statement, okay? Reading something is, normally, in many languages, you have an input statement where the program stops until the user types something. But in that case, it will block the whole application. So the readline library, which is one of the libraries that can do that, for example, this is an interaction implemented in an asynchronous way. So, for example, there is this question. I pose a question to the user. It will write this message to the console, and then continue. Look at this statement, arral.question, open parenthesis, close parenthesis there. Okay, so if I execute this synchronously, the only operation that I'm doing is calling this function, question, that will print the message, but will not wait for the response. There is no return value from this function, because I will execute this and then go forward with the code, and I will go forward before the user had any time or chance to type their answer. So when I call a function that implies an asynchronous operation, normally there's no return value on this function, from this function. What is the return value? What is the string that the user typed? Well, if and when the user will type something, then a callback will be called at that time in the future, asynchronously. Well, and this is the callback function that will receive as an input the answer and can do something with that. So actually, we need to shift a bit our mind. The return value of a synchronous operation is actually the input parameter of an asynchronous callback. Okay, so you don't find the return value out of the function that you're calling, you find it as an argument to your callback. The arguments are provided by, in this case, the library, the question function, that will call your callback when some data is available. This also means that if you have to process this answer, you cannot do that in these lines of the code here. these lines of code here, if we add any lines of code down here at the bottom, they will be executed before getting the answer. And the rule is that a function runs up to the end. So we are sure, even if they're usually extra fast, this callback will never be called before the synchronous code to which, the synchronous function to which this code belongs is finished, is completed. Okay, so it's for sure, there's not a race condition, may happen or may not happen. It will not happen. Okay, so in many cases, when we run, or we schedule in this case, an asynchronous operation, normally we don't have anything more to do. It tends to be the last element in the function. Because even if I proceed with this function, I don't have the data yet. Okay, so there's no return value here. Okay, up to this point, I know that I need to do something that implies an asynchronous operation. I schedule the operation, and they go away. Because I know that something will call me when I will be able to proceed because the data will be available. And this is good for a lot of different asynchronous operations, like I mentioned, user actions, input-output operations, intervals or scheduling, so when you have maybe an animation where something needs to change over time. Or today we are going to start with one type of input-output operation, which is interacting with databases. So we are not going to do any console input-output, we are not going to do any file input-output, because it's very seldom useful in the context of web applications. Instead, we are going to play with the database interfaces. Okay, the easy methods are, we already started to see last week, for the easiest method for scheduling some asynchronous operation is using the time as a trigger. Okay, so like you said, the setTimeout function will schedule a given callback function after a given number of milliseconds. We played with this last week. We saw that when we do something, for example, in this code, the hi message will be printed right now, and the hey message will be printed after 1 second. Okay? And now we understood why. When we execute this setTimeout, we are actually putting a new function, the desire of executing that callback into the event queue, and actually the timer will put it only after this time has passed. So the work of setTimeout is taking the function call and only appending it to the event queue after 1 second, after the given amount of milliseconds. Okay, and well, this is another example of a function that will receive some parameters, but it's seldom used. SetTimeout sets a timeout to run once. SetInterval will set a timeout to run periodically. So SetInterval or a function with 1000 milliseconds means that every second it will be executed. So we started running or scheduling this callback periodically from now until the end of time. Okay? The only difference between a timeout runs once, an interval runs periodically forever or until you clear the interval timer. Okay, maybe at some point you don't need to do it anymore. For example, intervals are used for doing animations. Okay, you take a block here from here, you move it there. You want to make the movement smooth. So instead of moving it by half a page, you only move it 10 pixels at a time every 10 milliseconds. So every 10 milliseconds you have a timer that will tick, and then the callback will just shift the element a bit. And then another 20 milliseconds, another little shift, and so on. We cannot do that in a loop, waiting for me. There's no wait statement in JavaScript. okay, do this and then wait and do something else. No, the only way of waiting is go away and be scheduled after 20 milliseconds or so. And when the movement is finished, of course, you don't need this timer anymore. So you must shut it down. So the setInterval function will not only schedule this function to be executed every 200 millis, but will also return a handle that refers to this interval, and this handle is basically used to clear it, to shut down the sequence of events, of scheduling. Okay? So we can set it up. In a timer, we set it up, it will run once, and that's it. In a timer, we set it at the beginning. It will run many times until we close it, until we clear it. And what happens when something goes wrong? It's a bit of a problem, because when I'm scheduling some function, some asynchronous operation, I know that the operation will happen later. What I said is that the input parameter of the callback would be actually the output of the operation that I've been scheduling. And so the function must take care of the output of the operation, so its inputs, and do something with those. And if this operation that I scheduled goes wrong for some reason, the function, the callback, should also handle that. So the callback, when it will be called normally when the operation is completed or when something went wrong. The callback must understand whether the operation was successful or not and act accordingly. In a synchronous code, we would throw an exception if something went wrong. Find not found exception. And so there will be something in the enclosing synchronous context to handle this exception. In an asynchronous code, I cannot do that, because there's no code being executed that could catch this exception. So we will see one mechanism from the syntactic point of view, look like an exception handling, but deep down, there's no intrinsic mechanism for doing that, for asynchronously catching some wrong operation. And so there were some practices, best practices, no rule, some practices that the callback itself should be able to understand whether the operation were successful or not. For example, the read file method for the file system module, which is used for reading a file, okay, you give a file name, and we call your callback with the data, and the data is the content of the file itself, a string with the file content. This callback actually receives two parameters, two arguments. One is an error message, and the second is the actual data. So it's just a convention, not all functions do that, okay? But a convention often used by the library is that I give you the first argument that if everything went right, if it's okay, if it's successful, the first argument will be null. If the first argument is not null, then it contains the reason why something went wrong. An error message or an error code or an error object, depends. And in that case, the the further arguments are not useful because they're not meaningful. So either the first argument is null, and so we can use the data because the second argument is meaningful, or if the first argument is not null, then it's an error and we cannot process the data. Yes?
In this example, if I have an error, the error usually is a message or just a number?
It depends. Some function, the error will be just a number. In some functions, they will pass you a message, a string, and some other will pass you an object with different fields. It depends if you need to check the documentation of the specific function, how an error is represented, actually. And we'll see what kind of errors we'll get with database, for example. So for doing some meaningful example, let's learn how to do input-output and run queries on a database, okay? We try to make it simple. So normally, a database, we know you have a DBMS, which runs a separate process. You must connect to it. You must run queries, and so on. And it's the normal case in which you need to have your application separate from the DBMS. It can be also on a different server with scalability issue, and so on. We'll try to make it simple. So the simplest type of database we can use is SQLite, which is an on-file database. So in SQLite, there's no database server that you need to connect to. The data just stays in a file, and all the DBMS system actually is a library in your code. So it's your code, your process that actually manages the data with some interpretation of the SQL syntax. Okay, so it's quite easy. It would be a problem if we had a real, a large-scale application where there are many concurrent users trying to access the same database, because it's just a file. So it doesn't work well under load condition, because when you are doing an operation, it will block other users for doing that. Okay, so it's not a long-term solution. But just be very quick to implement. So in this course, we will try not to complicate the architecture on the server side, and so let's go for this minimal choice. The concepts are the same, but we just have one less step to execute, so to run the DBMS and open the connection and so on. Okay, so SQLite is actually a C library, a library written in C. It's an open source library, and there are several JavaScript libraries in NPM that just load these C libraries and give you a JavaScript interface to the main function. Okay, we are going to use the basic one. It's called the library is called SQLite 3. So you need to install SQLite 3 on your project. So like I wrote in the message, npm init for initializing the library and npm install SQLite 3. It will provide you a library called SQLite that contains methods for connecting and running with the database. The database itself will sit into a simple file. It's just a binary file that you can have in your project. And we have a constructor function. Now you recognize the pattern, new with the name of a function that begins with a capital letter. So the type of constructor function that we played last week. You can call it a class or a constructor function, is the same. It's the same type of construct. And the constructor has two arguments. One is the name of the file where data is stored, and second is a callback to be called after the connection is open. Connection, like you are opening a file, you are not connecting to a server. And you see that this callback only has one argument, because normally when you open that file or open a database, that you have nothing to do. But the callback is just there to check whether there was any connection error, any opening error. Basically, if the file doesn't exist, it will be created. The error will just be whether the file cannot be opened or cannot be created to permission issues, for example, or wrong characters in the file name or something like that. And you see that this error will happen asynchronously. So we ask the library, open a file, and then we go forward doing something else. In the meantime, the file will be open, and if something goes wrong, we get an error. But actually, the statement in this line, where the mouse is at the moment, doesn't know whether the file was opened correctly or not. because probably it hasn't been yet opened yet. So we cannot use this error information in the following lines of code. We should say, okay, let's go forward, and we know that if something goes wrong, that asynchronously we will handle it. This is a bit of a special case because all other functions that we may call on this database object internally will wait until the connection is made if by chance it's not being connected. So internally they're doing some waiting, because otherwise we should explicitly wait for the connection to be done. It's a special case here. Okay, it's not a fully asynchronous pattern. But after this, we can work with the database with a handful of methods. Okay, we can run a query, and normally the DB is the database object that we created by calling the database constructor, which has actually normally 3 parameters, 3 arguments. db.all means from the database, give me all the results to a given SQL query. And SQL is just a string with a statement, the first argument. The second argument is the list of parameters of that query. So, okay, there may be or may not be any parameters. For example, if you have select everything from table, we have no argument. Okay, so we'll just a string, and we don't need the second parameter. But if you have select all elements, all information with ID equal to 7, okay, this 7 is a parameter, is an argument that you want to pass separately from the string itself. We'll see an example in a minute. So the arguments of the SQL statement. And finally, the third argument is the callback, to be called when the query is completed in the future. So I'm saying, please run this query, and when the query is completed and you have the results, call me with this rows parameter, and rows will be an array of objects. The array will contain as many items as the rows of the result of the query, and each object inside the array, each item of the array is an object with all the fields corresponding to the columns. Remember that the select query will give you a table, rows and columns, and is mapped in JavaScript as an array of objects. Let's see an example. I made, if you loaded that in the project, a simple database in this file. In week 3, you find a file called qa.sqlite, which is a small database for our question and answering exercise. Okay, we will play with that by implementing the exercise number 4. But for the moment, let's just see. When I click on this file, right now I can see the content thanks to an extension of Visual Studio Code. There are several extensions that let you play with, where is that? With SQLite files. I chose this one because more or less it lets me do what I want. There are also others, simpler or more complex. You may also use any external program, because there are a lot of other user interfaces for SQLite, command line interfaces for SQLite. SQLite is standard, okay, the format of the file. So you can have many different tools for doing that. I find it just useful. The interface is not very clear, it's a bit confused, but it does what we need to do. So actually we have this simple database with 3 tables, answer, question, and user. Let's see, maybe user, okay, the user table. A user table is a table with 3 fields, which is an ID, a name, and an email for the users of this application. Okay, so we imagine we want to have the list of all the users in our application. Okay, So let's open a new file. I call it queries.mjs. Okay, and we want to connect to that and get the list of users. So we need first to import. We have here SQLite from the module, SQLite 3, and open the connection. Database, well, DB, for example, is SQLite.database, and the file name. File name is qa.sqlite. The first argument. The second argument would be the callback to be executed in case of errors. So in the case of error, you see, the callback is always called, so we need to check, we always call with an error equal to null or with something. So that could be, if the error is not null, then, I don't know, a console.log db problems error. Okay, if we run this, sorry, I forgot the new keyword. Okay, it's always good. I'm a bit of paranoid. I run the code every couple of statements because okay, so it's not doing anything right now. Just to see if I modify the file name, so it's a wrong file name, it doesn't create an error, but it will actually, it should actually create a new file. Sorry, I didn't save it. So if I save it, you see that it doesn't create any errors, but it will create a new empty database. So beware, if you mistype the file name, you will be working with an empty database later on, okay? But it doesn't cause an error. Okay, so let's remove this because we actually don't want it. We want to query sorry. Did I do something wrong here? Did I delete the wrong file?
You are not in the folder free notes.
So let Git help me.
If you go back to the folder, you have two files named QA.
Okay.
And you are in the wrong.
Okay, this one is good, right? I just recovered that from. Okay, so we wanted to query database, so we want to actually execute a query, a simple one, as select everything from what's called user singular form. Okay, I don't have any argument here. So I want all of them, so you use the db.all method from the database class, and the arguments of db.all is the SQL string, the callback, and possibly, so the string and the callback, or a string, the parameters, and the callback, the other form, where if I want to provide some parameters to the query, I put it as a second argument. Or just the string and the parameter with no callback. It would be not very useful because I don't do anything with the results, but there are these three formats. Okay, we are going to use the first one because right now we don't need any parameters. And so is the function itself that will check whether the second argument is an array. It will interpret them as a list of parameters. If it's a function, it will use it as a callback. Okay, there's a bit of logic inside. So the query is my SQL statement, and what I want to execute is a callback that will receive an error or null. So an error of, you see, error means an object of type error will be SQLite.error. We can check what this object contains, but it's an object, or null. So the argument error is an error object or null, and then rows is an array of any type. This is what it is saying. And this callback doesn't need to return anything. There would be nobody listening, by the way, so there's no need to return anything. Okay? And we also see that the return value of the all methods is a database object again. So it's very common for a synchronous operation to return an object of the same type, so that the calls can be changed. It can have db.all again for running another query and so on. We are scheduling all of them in sequence, just a convenience for chaining, but we don't need it. So actually the two arguments here are the error and the rows. Let's use the standard naming. And in the body of this callback, we can handle the result. So, for example, I can have, if we have an error, then let's see what the error is. So we have a look at how this object is constructed. Otherwise, we have some rows that we can print, for example, for item in of rows. Rows is just an array, so we can iterate over it, console.log item. Yes? Do you specify?
Define queries as a string. Is there any another way to define queries? Select stuff
No, actually, in the basic interface to SQLite, queries are strings. There's a parameter method for having parametric strings, so that inserting arguments in there. We'll see in a moment. If you want something more sophisticated, you should do some or object relational mapping library, or ORM library that will let you create objects for building strings. This is just the bottom level, just the raw access to the database. Okay, so the string will be interpreter and will be transformed into instructions. So let's see if this works. No such table user. It created an empty. Okay, here and there. So that's the problem. Okay, the problem is that I'm running from the wrong. Sorry, okay, my bad. I'm running this with the run button, and I opened that's what you were trying to tell me before. Okay, I get it now. I'm running the code from the directory of the project, and it should be running from the directory of week 03. So let me open again the right folder. Okay, so right now I'm here. Okay, so this is okay. It's been running. The problem is my syntax here. I forgot to declare this variable. Save and run. Okay. This is the output that we get. We get 4 objects. You see that every row, we have an array of 4 rows. We can also print it. Rows.length. As we see, we have an array of 4 rows, and each of them is an object. So we have as many rows as there are results in the query, and as many, and each of them will contain an object. The property names of these objects are the columns of the query, and the value, of course, is the value. It can be a number, can be a string in the table, the value of the query result. Okay? So we can just use this information. We can use this information inside here. Sorry. Inside this block. This block is run when the query is completed without errors. What happens when I have an error in the query? Okay, let's say I'm not writing select, but selected, because I got a slip on the T letter when typing it. So this will be a wrong statement, of course, and when I run it, my code will go to this branch, because the callback will be executed with an error parameter which is not null. And actually it contains an error object. In the case of SQL library, the error object contains 1 number and 1 code. Okay, so it'd be error number 1 and code SQLite error. This is the error object that we are printing here with 2 arguments. Okay? And we are not doing anything else here, because in this case, the rows argument will be empty, will not be provided. So right now, the only thing we can do is to print the error in the console, but actually, we should be able to process it. Okay, so everything should be done here, because here the only place where we have the result of the rows. Can we return this somewhere else in the program? No. Okay, even if we try, no? For example, we have the users. We want to have an array of users, and we want to, once we have the items, we want to append them to this array. Okay? And so at the end, I can have the list of all the users. Okay? All users are users. Okay, so I'm initializing something, I'm filling that with the result of the query asynchronously, and then I will print the result of what are my users, so that I can continue the program with this information. And as you can expect, it doesn't work. It doesn't work because it prints that, sorry, users, again, stupid me. I always forget. What it prints here is all users are empty list. and it prints that before printing the results of the query. Now, the problem is that this program contains 3 statements. Let users is empty, db.all that schedules something to happen, and console.log users. And these 3 statements in line 7, 9, and 21 are executed synchronously in the same batch, in the same block. So I'm sure that this variable will not be modified before reaching line 21. Line 9 does not modify anything, does not run anything. It will only schedule something to happen, and when it will happen, it will modify the variable. There's a closure on the list. So the only way of getting the result is to do something inside this. So if I need to do something with the results, I should do it here, or here I should schedule some other callback to take over the results and do some work. No? That was why I was saying that after an asynchronous function, there's nothing useful that we can do, usually. We have no further information in line 21 that we had in line 8, for example. Yes?
Is there a way to know when a library function has an asynchronous behavior or asynchronous?
Yes, it's documented. Yes. So let's say that all library functions that have that manage input/output will be asynchronous. And you see that because you have a callback as an argument. Okay. Functions that operate on internal data structures tend to be like the functional, let's say, for all and each, and so that we saw last week are normally synchronous because they just operate on internal data. When reading the code, yes. If you don't know the function, there's no syntax element that will tell you whether a callback will be asynchronous or synchronous. Yes. Yes. It's there's nothing special in the syntax. It's just the behavior, how it's implemented. Yes. Can you? Exit. Sorry, I don't get.
We have something in JavaScript which is async and await. Await means you should wait for running this code.
Await. Oh, yes. Okay. We will come to await and async, yes, later on, because we are. After this, we'll see the promises, and after that, we are building that. Okay. But it's just a way of hiding this behavior. We need first to be aware of what is happening here. Yeah. Yes. We'll get to that. Okay, so that's one problem, okay, that we have to deal. Let's just see a couple of other functions that will go back to this problem. Well, the problem is it's just the fault of our synchronous thinking, okay? I do something and then I want to deliver the result. Actually, in JavaScript, we should think always that also this code would be probably in the response of an event, okay? The user click on something, and so I need this data. So I get this data, and I put the result in some part of the web page, and then I'm over. I don't need maybe to store the data for later or whatever. Okay, so also the type of operation that we need to do in JavaScript when we do input-output is just short-lived operations. I get a task, I execute it, I store the data somewhere, I do some output, and I'm done. There's no other code to be executed later, no long programs. A long program is just a collection of very small functions that will call each other asynchronously. Okay, there's other ways of running queries. One is the get, which is identical to all, but it only gets the first row of the result. This is useful when we know that the query will only return one result. For example, we're doing a count statement, no? An aggregate function which only returns one row, or when we are filtering on the primary key. Okay. So if I have a query where ID equal to 2, I know, because the ID is the primary key, that will only return at most one row, okay, 1 or 0. So it can be useful in this case. The difference is that you have one argument here which is not an array of objects, but it's just the object directly of the single row, or null if there's no row. Or each, which is sort of running a database.all query, but then instead of, so it will return all the rows, but instead of calling the callback only once with the full array, it will call the callback many times, one per each row, if we need to do something separately, row by row. Huh? I would say that in most of the cases, that's db.all is what we want. And this is for the select statement that returns some data. Then you have all the other SQL statements that don't return data but modify the database, so insert, update, delete, whatever. Okay, and since they don't return any result table, they have a different signature. Is run. They are called by a run methods on the database object, and you see that the function only receives one parameter, which is the error code. There's no data. That's just whether I have an error or not. Actually, there's some information when, for example, you are doing an insert of some information that is linked to a auto-incrementing primary key, which is very common. You have a primary key which is number that increments automatically, and the database does it by itself at every new item. So when you insert something new, you don't know the ID, but after the insert, you can have the information about this ID. And this information is not provided as an argument, because actually run doesn't know where you're going, whether you are going to make an insert or something else. It will be provided in a variable called this.lastID. So if you are making an insert inside the block here, you can use lastID, this.lastID, to extract the number that was just inserted. It can be useful sometimes. Just a warning, this keyword in JavaScript has a strange behavior. And actually, the behavior of this keyword depends on the type of function where it's defined. And it's the only case in which the function expression, you see that here I use the function expression, and in the other examples I use just an arrow function. The reason is that with an arrow function, that this object is not created. And so if you had to use an arrow function here, instead of the function keyword, this would not be defined. You will get an error. The explanation would be long, 1 hour longer, so for the moment we don't need this information about the behavior of this. No? We will give you a set of slides if you are interested in the different ways of use this variable. But long story short, when we need to access this, and in particular lastID in a callback, remember to define the callback with the function syntax, function expression syntax, and not with the arrow syntax. Okay, the function syntax would also be valid in the other cases, of course, but no, it will occupy more space. Okay, and finally, as you say that some queries may have some parameters, so select everything where, I don't know, maybe I'm only interested in one user, not in all of them. And so I filter, where's my code here? I can filter only the user where the ID equal to, I don't know, 2, for example. And these two may come from other variables. It's not something fixed in the code. User ID, the user ID that you want will be 2. So how to embed the user ID into the query? We don't want to do concatenation, of course. We want, yes, sorry?
Can you use, for example, brackets and the same, for example, user ID?
We will do that here in the query. So one possibility could be of writing using the template string from user where ID equal to user ID, something like that. So we could construct a query by interpolating the value, okay? And this is a definite no. Okay? No, because normally this number, this ID, this information comes from the outside. It's an input parameter of my code. And can be anything, including something like a user will type 0, semicolon, delete from user. Yeah? This is a simple example of SQL injection. If the user selected enter your ID 2, and it will do the query. But if at the prompt enter your ID, the user will type this, okay, when I interpolate that, I would have a query like that. Select from ID equal to 0, who cares? Then delete everything from user. So the user just typed something into an input form and destroyed my database. Why? Because I was trusting some data coming from the outside. Actually, what we would like to do is that, okay, yes, but no, but this, I didn't want just to interpolate the string. I would say, okay, user ID is one data, one item, and so it should be, I don't know, protected in some way. And separating, I need to tell, okay, the database that this is not SQL syntax. These are just characters in a string that is being passed to the query. But if I do some naive concatenation, I'm losing the difference between this where, which is part of the syntax, this where, which is part of the syntax, and this from, which is part of the data. So the mechanism that is provided to us is tell me when you have a parameter, question mark. And when you execute the query, give me that parameter. Sorry, not here. The second argument. Yeah. So I'm sending to the database separately the string, the query string, and the arguments. They travel on separate carriages. They are never mixed. It's the database that will know that, okay, this is just an argument, and in this case, it will be taken verbatim, character by character, and we'll check whether there's any field in the ID column which actually exactly matches the string, and there will not be. But it will never interpret the SQL code, possible SQL statements or special characters, because you see that this is an argument, is not the query. The first argument is the query as interpreted, and the second argument are the possible parameters, values, that the database will use whenever it finds a question mark. Okay? So never create queries by string concatenation. It's deadly. So if I, in this case, take a number, I remove this, it should only print only one user, because the query now filters only those who have this ID, for example, or any condition that we want, I don't care. So whenever we have a query that depends on some arguments, never embed the arguments in the string, but always pass them as separate parameter. If we have more than one argument, you will have more than one question mark in your string, and you will have, of course, more than one value in this array of arguments. Okay? Okay. So, okay, this is what the example that we had before. In a different example, trying to extract the result of a query doesn't work. Okay, we must find what works. And the other problem that I want to show you is actually these queries are executed, all queries are executed asynchronously. Okay, so I tried to do a very simple program, saying, okay, create a table with just one cell, one number, one row and one column, a number. And I want to insert new numbers into this table, many ones, 1, 1, 1, 1, 1, it becomes like that, and then count how many ones we have. It's a very sophisticated program that will append one line with a 1, and count how many we have, and then append another one and count how many we have, and so on, in a loop. Okay? So I expect to see an increasing number of counts, 1, 2, 3, 4, 5, because every time I append a new one, I will count them, and there will be one more than we had before. Okay? So I implemented this program, say, okay, let's append 100 numbers. For every number, run an insert into numbers of value 1. I append a new line. And then select the count for these numbers and log, in this case it's db.all, so it returns an array. I'm only interested in the first line and the column called tot. Okay, so row.0 is the first line, .tot is the field. What I got was this set of numbers. It's only 100, so I run it many times, so it will increase every time. Okay. So if you see these numbers, they're not sequential. They are not consecutive. For example, 396 happens 3 times, and 399 happens 2 times, and 393, 394, 395 went away. But I'm doing an insert followed by a count, and then in the loop another insert, another count, and so on. So this is ordered. Well, what happens is that the scheduling of the query is ordered. So I will schedule the first insert, then I will schedule the first count, then I will schedule the second insert, and then we'll schedule the second count, and so on. And the SQLite library will try to execute them, all of these schedule statements, in some order. Maybe some of them in parallel. I don't know, it will try to run only one at a time, or 5 in parallel, or 25 in parallel. It's internal tuning of the library. And as soon as every query that is scheduled completes its work, it will call the callback, and then I can print the data. So actually, the execution of these 2 blocks of code, the scheduling is linear, is sequential. The first insert is scheduled here, the first count is scheduled there, the second insert is scheduled here, the second count is here, the second, you see that there are, oh, okay, the last one is wrong. There are alternated. The scheduling time. The execution time doesn't depend on me. it's asynchronous, so some operation may finish before another in out of order, in an out of order fashion. So I cannot trust the operation to finish in the same order in which I scheduled them. I cannot trust in the second iteration that the query of the first iteration are already completed. And I should not try to fight this behavior. We should try to embrace it in some way. This example is stupid, but it's very, very complex to solve with the current syntax. No? That's why she was waiting for the await syntax. Because actually, for being sure that the counter comes after the insert, then the scheduling of the counter should be inside the callback of the insert. But also the callback, the scheduling of the insert should be inside the callback of the count. And syntactically, you cannot have something which is at the same time inside and outside itself. Okay, so you cannot do that. You should have this code, this red code inside this block, and at the same time these orange blocks inside here. That's not possible. You can do that. It will be very complex. You can manage your own queue of events, but so you are building in a way your own event loop. That's not something. That's not a road that leads somewhere. So if we need to do to be sure, okay, the order operation is conserved. If we need that, then we need to be careful of where we extract when we use the data, or we use a more sophisticated mechanism, which is called promises, that we'll see in a moment. But I don't want to put too much on the table right now. I maybe want to do some first exercises with this basic syntax, so that we get familiar with the asynchronous behavior, and then there will be two further steps. One is called promises, and the other will be the await statement. That gives some easier syntax to work with this stuff. But first we need to understand how they work. Okay? So for doing that, I would propose working with this exercise. Okay? We are following, where's that? No, so the idea is to we already used some objects last week for playing with the arrays, with functional methods. Now let's try to build a small application, okay, that implements some objects, in particular a question object and an answer object. Okay, we already have that. Now we have maybe more information, more fields, and stores this information in a set of database tables, which is the database that I already shared with you. So I already did this work of creating 3 tables: a user table, a question table, and an answer table. So instead of just having some example query like we did, we try to implement these 2 objects. One object we call a question that gets some method, get answers, add answer, what answer, for example. And another object we call the question list, for which we have other 2 methods to implement. So right now, we start thinking that the real data is stored in the database. And our objects are only way of getting in and out information, but the real information is in the database. It's not in an array, of course, for persistence reasons. The data should be stored somewhere. Where it persists is not something that is forgotten when we restart the program. Okay? So, if we want to start just the first step of the implementation, we should have, let me create a new file here. exercise 4, where we have the solution or exercise, let's say exercise 4. Okay? So the exercise says try to define some objects and implement some methods. Okay? The objects are the question object. So we define a constructor function for that object. Function, question. Okay? With some arguments that are the ID, the text, the questioner ID, let's call it sorry, let me check how I call that in the database, the author ID. Author ID. And then it asks me also to store in the question the email of the author, quindi author email, and the date. Okay? So we have these arguments, and we just create an object with this.id equal to id, this.text equal to text, this.author ID. So it's a constructor after all. Author email, and finally, and this should be a date.js object, okay? That should be already constructed and passed as an object. And then we have the answer object, okay, function answer. Yeah, okay, I never write function right the first time. We have an ID, text, the responder email, responder ID, so it's a user ID, user, let's use author again. The author of the answer. Author email, and then date and score. And yeah. And we do all the game of initializing the object. And this dot date equal to date, this dot score equal to score. Okay, so these are the raw objects, and we need to now add the methods for them. By the way, we have this hint that says, okay, but the editor recognized that we are building a constructor function, and so he offers to convert this constructor function into the class syntax. Okay, so there are different, they told me that in the lab some of you were using the class syntax. It's okay, it's just a different syntax for the same thing. You see, you are not saving a lot of keystrokes for doing classes, and okay, you can define method down here, like you can define method in the function syntax. Okay, there are actually two different syntaxes for doing the same thing. Okay, if you feel familiar with classes, it's okay. You can just use this syntax, and from the usage of the object, actually using it is the same. You know, whether it's built by a constructor or by a class, so you create it with new, and we call the method in the same way. So just feel free to use the syntax that you are more familiar with. Okay. So finally, before the break, let's see what we have to implement. In the question object, we have to implement a get answers here. This dot get answers that gets, sorry, not here, in question. This dot get answers is a function that returns the list of all query database and return an array of all answers to this question. Okay, so this will be the first function that we implement. So basically a query that can be called by an external program and we can try it on any question object. Okay? We will implement it first using the functions that we saw before, and then we understand what it means return a promise that resolves, which is a better way of doing that, of implementing the same thing with more control over the return value. Okay, so let's first, after the break, do that with the normal syntax, with the basic syntax, and then we'll learn about how to do that with the promise objects for doing the same thing. Okay? So let's have a break of 15 minutes.